Hello and welcome. In this video, we're going to take another look at our P5. We are going to focus in on how to now print out the results from our calculations, in this case of our circle geometric properties that we have calculated in an earlier video. This video assumes a couple of things. Number one is that you've been following along with the earlier videos, but also that you have a copy of our P5 sample.txt. Now, in this particular video, we are going to only focus on printing to the console. I'm going to save the printing to the file for another video. And what we're going to do is we're going to focus on building this nice little output table. And you'll notice here that basically what I have is a combination of column headers, and our first column is consumed by row headers. This is going to be a slightly different format than what we use in our CSV file, where we do not actually use column or row headers. And again, you'll notice here that the data is oriented horizontally. So the idea is that I want to see all of the radii in one row as opposed to in one column. So basically all of the same data is going to be in a row for this particular example. So let's go ahead and get started. In the earlier videos, I've already created our switch structure and have finished our functions. We haven't yet tested them. We're going to do a little bit of that this time around, but fundamentally the workflow that we want to look at is we're either going to collect the information interactively or parametrically. Once we have collected the individual pieces of information, then we pass it to the function. If the function is successful, we now want to print out the results. And we're going to start again with the table. And so the first thing that we want to do is we want to borrow some of our P5 sample. And so to begin with, what I want to do is I want to think about how can we actually print out this table so that we can control the number of columns. So remember that n is a variable that can be passed by the user. And if anything, you can go back to your P3 modified. You can see some of the tricks that we employed there. But fundamentally, the idea here is that all but the last column should be separated by commas, and then the last column should have a new line. So effectively what we're going to do is we're going to be stopping at the last column before moving to the next line. Well, to accomplish this, then we first need to make sure that we have a variable that can be used to loop through our parallel arrays, and we do. So we're just going to simply leverage our index variable. The other thing here is you'll note that I will be focusing in on the interactive example, and then we're ultimately going to be doing the same thing with the parametric example. So let's go ahead and get started here. And we'll set up our for loop. We'll start off with for index equals 0. Remember that we want to stop before our n, but in this case, we want to stop even one short of that. So for index less than n minus 1, because we want that last column to be different than the previous ones. And then we will simply increment our index. Now, again, my goal here is to have this portion of the table extend out as many columns as it needs to. So let's get started now on actually printing. So outside of the for loop, I want to print that first portion of the table, and that is going to be simply the word field followed by then a comma. And notice here, I'm not going to have a new line. I'm going to essentially just stop printing, but not go to the next line. And then inside of the for loop, I'm going to have a printf that is going to then print out the field number, which is going to correspond to the index. Again, note that I do not have a new line, but instead a comma, and I simply will leverage now my index variable. And then I do the same thing for the last column, in other words, outside of the for loop, but the difference is I remove the comma and I replace it with a new line. And then we will simply then hard code in these these row barriers. We can also go through and lengthen these as necessary. There's a few tricks we can play with this, but for right now, we're going to leave this just static. And since we know that we're going to need two of them, we're going to go ahead and put the second one in. Now, before I go any further, I'd like to see if I'm on the right track. And so I'm going to go ahead and build this. And if we don't have any errors, we can come back out to our console. And I'm going to test this thing interactively, again, with the default values that I put in the sample file of 1 and 0.75. And this is actually our first opportunity to test our function, and it seems like it's working correctly. You'll notice here that I have made one minor mistake. It's the relationship between the value that we want to calculate, in other words, which one it is, versus our index. You could leave this as is if you wanted to, but the user would probably be a little bit confused because they might not understand that C is in fact zero-based indexing. And again, since this table is more for the user, let's just simply come in here inside of our for loop, and we will simply print index +1. And likewise with the other printf. And again, we're going to build this one more time. We'll run it. And at this point, you now have your column headers set up to be controlled by the number of values specified by n. Now you can play around with this some. As a matter of fact, I encourage you to go ahead and start using batch files and using an input text file so that you don't have to go through and manually enter in all these values over and over again, especially as you start working on your other functions. But it seems like we're on a pretty good path here for a start. So let's focus now on the additional values. And so what we're going to do is essentially we're going to duplicate this same process right here. The main difference is, of course, that we are not going to be using the field. Instead, what we're going to do is we're going to leverage each one of these row headers. And so what I'm going to do is inside of our horizontal bars here, I'm actually going to do it once using a printf, and then radius specified with inches. Remember, the first one is going to have a comma, and then the for loop is going to simply start back over at 0, incrementing up to, but not including the n-1 element. And then we increment our index. And now inside of here, we're going to use another printf, and we can use the format spec that we agreed upon in class, or the one that I had originally initialized or gave in the initial instructions, and that's %8.4f. And that part doesn't really matter too much for this example, but we have then a comma for the values inside the for loop. And then what we can do is we can now plug in the individual values of our radii vector. In other words, not a single radius value, in other words, not radius max or radius min, but instead what we're going to do is we're going to pull out the values in our parallel arrays. And again, no shifting of the index is necessary here, but we do, however, duplicate our printf statement, with the only change being now to a /n for that last column. Now, again, what I'd like to do is I'd like to go ahead and build this, make sure that I have no mistakes, but run this because I think now this will become very clear what we are trying to do here. And I'm actually going to put a different number in here just to prove that we have some flexibility. You'll notice here now I have 4 values starting with 0.75 all the way up to 1. Now, the only thing that I did specify in the sample that we have not done here is that I'm actually specifying the largest value first. Well, it turns out that that's not too terribly big of a problem. What we can do here is we can actually count backwards using the value of n. And what do I mean by that? Well, if you think about it for just a second, if n is 4, and we specify n minus index, and index starts at 0, then we're going to get the first value of the for loop being 4. But remember that we have to shift or take account for C being 0-based indexing. And so what we can do is we can do n minus index minus 1. Now, if we do this in both places, then let's think a little bit about how this will work. The index will go from 0. Technically, it will stop short of 4 minus 1. So in other words, this portion of the loop will go 0, 1, and 2, 2 being the highest value then. So it's going to be n, or 4 minus 2, which is going to be 2, then minus 1. Let's see how this plays out. And so if we run this one real quick, you'll see here that what I've effectively done is I have just simply reversed the order of our printing. And so we'll start off with our largest radius all the way down to our smallest radius. So what we're going to do is we're going to keep this pattern. And effectively at this point, we can cheat a little bit, meaning that we can just simply come along and do a copy and paste. And as long as you are careful with switching out not only the text in the print, but also remember to change then the array that you are accessing. In this case, we are going to be accessing the edge. Let's do one more before we test our application again. We're going to move on to the area. I think I accidentally grabbed our little horizontal border there. There's our area. You could probably use Notepad or something along those lines to do a nice copy and paste job here. But let's go ahead and build this. Let's see how we're doing. We should now be putting a nice little table together. Again, 4 values here. And you can see that it's coming along rather nicely here. The only thing that we have to do is we have to change the units here. You notice I have inches for edge. That makes sense. Inches squared for the area. So we'll need to come in here, clean this up a little bit. But effectively now we should have a nice little process here. So we're going to do one more. Actually, we can then simplify this in just a second here. There'll be IX, which is going to be technically to the 4th. This will be our IX, and then again, IX. And at this point, then these last couple are going to be very consistent. They're all going to be to the 4th. The only difference is it's going to be IX gets changed to IY. And then our IX, of course, will get changed to IZ. And at this point, we should be pretty close to being done. So let's go ahead and build it one more time. Let's come out here to our command window. Test R1, test R 0.75, 4 values, and you'll see then I have calculated my radius, the edge, the area, IX, IY, and IZ. And as a quick sanity check, you'll notice that our IX and our IY do actually make sense. They match. You also probably want to do another quick sanity check and notice that the radius and the edge, that makes sense because that's going to be 2 pi, and that is back 2 pi. And likewise also with pi r squared. So hopefully you've found this useful. The only other thing that we want to do real quick is, of course, go ahead and bring this over to the parametric branch. So this is going to be a little bit of copying and pasting. I'm actually going to show you in another video how we can improve on this concept ever so slightly. But for right now, what we're going to do is we're going to copy this entire block. into the exit success branch of our function call for our parametric. Regrettably, in this particular project, there will be a lot of duplicate code. We'll work to remove that. But if you go ahead and build this, you can now test this using your parametric switch, passing the same values here, and you'll see, in fact, you get the same table. So as always, hopefully you found this video useful. If you have any questions, comments, or concerns, don't hesitate to reach out to me, and thank you for watching.